Last example in 11.2. Oops, it's example 5. It says, find a power series representation centered at 0, so it's a Maclaurin, for the following functions. So part A is arctan. Now, the easiest way to do this is if you remember that the integral of 1 over 1 plus x squared dx is the arctan. And we just finished doing this one. This was example 3C. We had said that 1 over 1 plus x squared turns into 1 minus x squared plus x to the fourth minus dot dot dot, stuck in those boundaries. So let's integrate term by term. This will give me arctan of x is equal to, integrate 1 and you get x, integrate x squared and you get x cubed over 3, and then x to the fourth turns into x to the fifth over 5, and it's alternating, plus some constant c. And so now, if I plug in what I know, when x is 0, the arctan of 0 is 0. So the c in this case would be 0. So I don't have to worry about it anymore. And so now let's just turn this into a summation. Okay, I need odd powers. I need it to alternate. I need it to start with a positive. So I'm going to start at 0. And then I'm going to say negative 1 to the k. That will guarantee the first one's positive. And then I need to get an x to the first power. And I'm going 1, 3, 5. So if k is 0, to guarantee an even number, it's 2k. To guarantee an odd number, it's 2k plus 1. And if you stick in 0 there, you'll get x to the first power. And then the bottom is the exact same number as the power, so I want a 2k plus 1 on the bottom. Now, if we check the endpoints on this one, if you check, because our interval is still negative 1 to 1, if I stick in negative 1, I end up with all odds, okay, an alternating of 1 over 2k plus 1, which that goes to 0. And if I check, so that was checking negative 1, so that one worked. If I check 1, that converges. If I check 1, I just also get an alternating version of it, so it converges. So my endpoints are inclusive, so my boundaries are negative 1 to 1. On part B, the natural log of 1 plus x over 1 minus x. Okay, in example 4, we just finished doing this. We noticed that the natural log of 1 minus x is negative x minus x squared over 2 minus x cubed over 3, and so on. No, not plus, minus. And if I replace every x with a negative x, I will get the 1 plus x. So that's going to make this one's going to be positive x, this one's going to be, replace every x with a negative x. So x, that's going to be negative x squared over 2. That's going to be positive x cubed over 3. So if I'm talking about the natural log of 1 plus x over 1 minus x, that is the same as natural log rules. It's division, so it turns into subtraction. Numerator minus the natural log of the denominator. And then we start putting in what we just said we had. The 1 plus x is x minus x squared over 2 plus x cubed over 3. The next one will be minus dot dot dot. And then I'm going to subtract from it the first one. And they're all minuses, dot, dot, dot. Interesting things happen here. If I combine things, I get 2 x's. The x squares cancel out. I get 2 of the x cubes. The x to the 4th would then cancel out. So this is going to turn into 2 x's. The even terms are canceling. And you may have to write more terms to see that. And the odd terms, you're getting double of them. Which means if I want to write that as a summation, it would be 2, the summation, k equals 0 to infinity. We only have positive answers. We need to guarantee odd exponents. So I'm going to use x to the 2k plus 1. When I stick in 0, I get 1. When I stick in 1, I get 3. And the same thing on the bottom. So there's my summation. That's the difference of 2 power series. They both converge on the interval -1 to 1, so this one also converges on the interval -1 to 1. And that concludes section 2.